So Lee, when he was having a tidy out, gave me this electric bike. It's a Yamaha. Had no batteries, and the original batteries, which were nickel metal hydride, died a long time ago. But it's got some interesting features. It's got 2 power modes, drum brakes front and rear, and a 4-speed hub gearbox, which is very nice, very easy to use. Yeah. And I put these batteries on here. They're 12 amp hour lead acid, the sort of gel type, but I'd taken the tops off and put some extra electrolyte in there and done 1 or 2 extra bits. If you notice, the box on the back on the far side is bigger because I added 1 more cell out of one of those 12 volt batteries, so it's actually 26 volts. However, the batteries weigh quite a lot, and when we were fixing that Solace inverter, Lee had said a while ago that he knew where there was a 70 volt lithium ion battery pack with a faulty BMS or a fault of some form. So he was able to get that for me, and we've done something with it, which is wonderful. It looks like we're going to be able to build a 20 amp hour 25 volt lithium ion battery pack, and I bought a BMS for it, so why don't we just go and get it wired up. If you notice here, he suggested using your standard computer type, kettle type plugs and sockets, so you can just unplug stuff and it's easy and this, that and the other. So I've gone with that, and I will have to find or use that socket there for the new battery. Right, let's crack on. So I broke the pack down into 25 volts, and there's another lot over by the charger of 3 rows, which will make 12 volts. So it's all very useful, and these are LG cells. I think they're 2.5 amp hour. So there we go. Where are we? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7. So the voltage adds up. So we've got 9 times 2.5. So that should be plenty. And that actually weighs less than that 12 volt lead acid. And of course the bike has got 2 of these plus 1 extra cell. I ought to weigh things later on and just keep that as a record. So what we need to do now, we get rid of that, is we have this battery management system and the wiring diagram, and somewhere we have the balancing cable. Now we've got to get this right, so it's a matter of taking our time. But one thing it does say in there is when you're actually soldering on the main power leads, make sure this bit is disconnected and then plug it in later. So let's get the soldering iron sorted out. That, I believe, is the negative. Yeah, and this side here where I've chopped it is the positive. So I'm thinking 2 cables off there, 2 cables off there, and it will go in one of those boxes, and then this will probably go up there somewhere. So that'll go in a box. We'll have a piece of wood across there, and that can go in the top. And this is a waterproof one, but that top there is a heat sink. So we're just going to have to work out how we're going to put things together. But that doesn't want to be fully enclosed. Right. Soldering iron. Tidy the decks. Think what we're doing. Crack on. Right, I'm just checking things. This pack was virtually flat when I got it. But because it got a bad BMS. So I charged it up on the bench power supply really slowly. Can't see what that says. 27. That's the positive, that's the negative. So yeah, really slowly at about sort of 300 milliamps for days and days. So as it's got 2 cables, provision for 2 cables here, let's do the same. I'm not sure how long these cables will need to be. But notice that steel cabling on there, we'll get rid of that. Right, where's the end of this solder? There it is. Tin the end of this. So this soldering iron came out of the scrapyard. I thought, oh, it's a Weller. Oh, that'd be interesting. And of course I tried it and it didn't work. I thought, oh, there you go. Nothing lost. But then I thought, hang on a minute, let's see if there's a fuse in it. And somebody had taken the fuse out. No doubt for something else. So I put a fuse in it and away it goes. And it's quite a nice one actually. It's the one that I use for repairing the Emerson, because it's got plenty of heat. Bit warm. So how long does that want to be? Well, I've got plenty of cable, so let's cut it. Where will it go to? The negative, according to this, goes to negative on the board. Let's get my other glasses. So the negative goes to, goes to the negative on the board. So where are we going to put the board? We're putting the board up here. Okay, so B negative goes to there. Oh well, we could just about go straight to there, couldn't we? And that's quite a fat wire. Okay, and the positive goes straight to the connector. Okay, and then we got the negative from the motor goes to P minus, power minus. Okay, so let us just cut this back a bit. And it looks like it's got silicone wire, and it has been tinned on the end. So let's put this here. Let's just tin it a bit more. Okay. So I'm assuming that wants to go round like that. Don't quite like that. We need a little block to hold that on. There's another block. There we go. Good. Okay, now I've got to be careful. Actually, it will go something like that, won't it? Yep. So power negative, which is there, goes straight to the negative of the motor. That's fine. Okay, so now we have this. So the black one, the black wire goes to the black. So effectively, I think that only fits in one way. Yep. So that black wire there goes to there. I'm going to leave it plenty of wire. I can always shorten it later on. If I don't have enough, it will be a right pain. But the way this seems to be working, it's fine. Soldering iron. So the black one goes to the negative buzz bar. And there we are. Okay. So the red next to the black the first red wire goes to between the first lot of batteries on the negative side. Okay, so we have, luckily, because this came from one of these packs, we have all these links already here. Alright, and there's the black link already, but we've gone to there, so that can get cut off. Okay, now the first white link, so between, that's the negative, between there and there is 4 volts. So the first red wire goes to the 4 volts, which is about there. I mean, obviously the battery gets charged through these wires, so the shorter they are the better, but I'm just being cautious. Okay, so let's just remove that, and that one goes on there. There's a lot of gunk on this. I think I might have laid it on something, so I'm just going to clean it off. I think it's melted something. That's better. Might have melted a bit of plastic or something. Right, keep focused. First red goes to there. The second red would go to the 8 volts, which is there, 7.9. That's good. Okay, so the second red goes to there. Okay, so remove that. The second red goes to there. Okay, this is not as taxing as I thought it might be. First red goes to there, second red goes to there, third red. I have done this before with another battery pack, and but that's one that I built up, and you did have to focus quite a lot, but we've already got these tabs here, so it's sort of half done. Just have to make sure we've got the right wires. Okay, so this is the third wire along from the black, and that goes down to 12 volts. So from the negative to there is 11.9. That'll do. That's 12 volts. Remove that, and this comes down to There. Okay, so then the fourth wire, the fourth red wire, just tin that up. Okay, so from the negative to there should be, yeah, 15.7. That's good. Okay, and then this comes down to there. Okay, right, next one. 1, 2, 3, 4. The fifth one obviously goes to the next one, which is there. Down to there. So hay time's over. Everything's baled up. Most of it's in the various sheds. That's great. It's great in one way because, you know, in a few weeks I'll be able to top the meadows and whatnot. And it's not in another way because it's like, ah, yes. We're halfway through the season. You know, the nights are starting to draw in already, and it's this whole thing of I'm hoping we're right here. We've got 2 reds left. There. Oh yeah, and there's one there. You know, the nights are drawing in. We've got. Shouldn't really be talking when I'm doing this. Yeah, half the year's gone already. Yeah. Although it's, you know, the vegetable plot is producing very well. Tomatoes are starting to ripen up. Beans are growing. We've had carrots, etc. already. Just going to sit this up. That is the 6th one which goes there. The leeks are doing remarkably well. That one. And then the last red one goes there. So it's nice of Lee to sort this pack out for me. He told me about it quite a long time ago, and I said, oh, could you sort that out, see if you can, because the guy didn't want it, and I'm pleased that it didn't get scrapped or anything like that. Now, how are we going to do this? I think we'll go to that one there. I think we might just have to wire brush that tab. But then of course we had COVID and lockdowns and all sorts of things. So it just, nothing came together very quickly. last wire. There we go. Right, so that goes on there and that would plug into there. Okay, so the negative from the BMS B minus goes straight to there. Fine. Okay, then a positive from that other rail goes straight off, and a negative from the return from the motor or the charger goes straight to there. Well, that's not rocket science, is it? So we need a brown that goes to the motor. And I just said to Lee, I think we've got a relay fault here, and as soon as we took the top off I could see those Zeta relays. I thought, oh, I recognise those. And then, well, you'll have to watch the video. It's a bit piecemeal because it's in the, you know, we're in here and we're experimenting. And I wasn't really thinking too much about videos. Right, where's the... That's the negative. There. The positive is at this end. But Solace inverters are supposed to be really quite good. We want to go halfway along this buzz bar. So we'll lay it down halfway along so the current will flow that way and that way, rather than put it at one end and the current has to flow all the way along from that end to there. But with the charging it's different because that'll be a lot lower current. Little brass brush there. Brown. Here it is. I've been wiring this up for a while. Just been putting it off because I'm thinking, you've got to be in the right frame of mind, deep calm, to be able to do this sort of thing, just so that you don't get the wrong wire in the wrong place. I'm going to shut up now. I'm going to switch you off. I'm just going to check that I've done it all right before we go any further. Yeah, this was £22, so therefore we don't want to make it pop at the first hurdle, as it were. But I've wired it, according to the diagram, I've wired it up right, but I'm going to check. So I'm just about to remove this battery on this side. I've undone the wiring. But just look at this side. It's, as I said, it's got an extra cell on this end. You see that link down there? You might not do. Anyway, there's a full pack and then another cell, and of course I've cut a battery up and then used the lead welding, the lead carbon welding technique, and I'll put a link to that. It's very useful when dealing with lead acid batteries and making new terminals and stuff like that. Anyway, I'm just going to remove this battery. I mean, this system works not too bad, but it's a bit heavy. And they're second-hand batteries from the scrapyard, so you know, good for maybe 4 miles, but hopefully this will be good for a lot more. And it fits in the same place, but I think we need a bit of plastic either side and a bit on the bottom. And I've got something somewhere. Okay, it's the moment of truth. Let me just talk you through this. That's not connected to the motor yet, but that's the original wiring to the motor. Okay, so positive comes from the bottom row. That's the positive. Yeah, and goes to the motor. Negative comes from P minus through a 50 amp fuse to the motor. Yeah, grand. So then all we have to do is plug this in, which is the charging system. Right, no smoke or anything like that. So I'm just going to put a bit of something, insulation, on the top of those batteries, and then check that we got power to the motor. Right, switch it on. We've got the lights. Splendid. That's a lot lighter and loads of power. I'll just show you the controls. There's the, and you just turn this bit. It's very easy. I'll have to get a new battery in that speedometer, mileometer thing. And here is the, you can have it on full bore, eco or off. And you must remember, well, you don't have to remember, but it's useful to remember, switch it off at the end, because otherwise it goes, after a while it goes dormant and you have to switch it off and then switch it back on again. That's if you leave it parked. But you're better off switching it off there and disconnecting it down there on that connector. But we're pleased we are. That's champion. So I can charge up through that connector there from this arrangement, and it's the same one that I used for the lead acid battery. But I think now I can put it in a box. Transformer, rectifier, smoothing capacitor and the appropriate output. So I'll put that in a box with maybe with a voltmeter on it, and that will do the job nicely. I think I'm just going to tidy everything away and give it a road test. It's a very comfortable bicycle. I wouldn't say it's hugely fast, but I'd say it's very easy. Power assist or pedal assist or whatever you want to call it, but with those pullback bars you're not leaning on your wrists. Anyway, hopefully you've enjoyed this. So there's another interesting project. I've learnt a bit there. The more you fiddle with these things and experiment, the more background knowledge you have. So please comment. Always nice to hear what people have to say, unless of course it's slightly abusive, which is a bit tedious. But hope you've enjoyed this and learnt something from it as I have. and I will catch you on the next one. Cheers for now.